Hello class, welcome back once again on our training for data analysis. In the previous videos, we have learned quite a lot of things that you have to know when you're embarking on your journey as data analysis. So, we learned a lot. And then what I want you guys to also appreciate now is about data cleaning and exploration. There are a lot of data out there, right? Or maybe you may like to go to a field and collect data. Once you collect the data, you have to be able to clean and let's say explore that data in order to make the data healthy for your analysis. So it's very, very important for you to know how you can clean and explore your data. So that's the reason why we are also today going to learn something about data cleaning and exploration. But for us, there are a lot of inbuilt data in R that in my previous videos I introduce you guys to that. So there are a lot of data in R that one can use as a source of practice for this journey. And then all this data that you can see in R, they are all really prepared. They are already prepared. They are already clean, prepared for the analysis, right? So they are, in other words, they are already healthy for the analysis. So for you to see all this data in R, you have to use a function called data, right? Once you type data into bracket like this one, and then you run, I will load that one for you, right? So R is going to load that one for you as you see. So it's going to change. So they have data set in package, that's data set, right? So we have air passengers data in R. Then we have a lot of data in R that one can use for his analysis, right? One can use this for his analysis. You have arrow as a data, right? A lot. You have arrays data, you have trees data, right? All these data are in R. So if you really want to, let's say, get some of them, you are going to learn how you can call the data into R. So if you really want to call a data into R, so here we are using what we call Harris data, of which is part of the inbuilt data that we have in R. So when you come here, once you come here, let me show you the inbuilt data that we have, right? The inbuilt data we have, what you are coming to use, Harris, right? So we have Harris. Where is Harris? So this is Harris data, right? So I'm come to call Harris data. So for you to call Harris data, you just put it into bracket, right? Data, as you can see here, into bracket of what this Harris in double quotation, right? Data into bracket of Harris of that. So once you run this one too, the data will appear, right? Nicely, the data is going to appear. So it's now loaded. So once it loads, I'll show you the Harris data, right? So at the end of the day, maybe you really want to, let's say, download this Harris data on what, your desktop, right? You really want to download this Harris data on what, on your desktop. So what you can do to download this Harris data on your desktop is to use what, write.csv, right? Write.csv. So this write.csv, right, will be the function that you use. So the first argument will be the data name. In this sense, we are using what, Harris. So that Harris is what, our data name, right? So at the end of the day, so as I was saying, we are going to use the write.csv, right? The first argument will be our data name, right? So this is our data name, the Harris is our data name, then the file. So this file will be, it's already stored in CSV, right? So here will be file is equal to harris.csv, right? And then row name is equal to what, false, right? Yeah, so this is the argument that we are going to use. So once you type in this argument, R is going to download this this CSV file on your desktop, right? So once I run this one, right, it will download it on my desktop. So when I come here, you see there is Harris data here. It has downloaded the Harris data on my desktop for me. So at the end of the day, it's in the desktop, right? And I want to really I want to upload it back into R, right? I want to upload it back into R. So in our last in our subsequent videos, we learned something about how directory, right? Yes. So right now my directory is a desktop, right? Yes. So if you haven't watched how we use the directory to call our data from our desktop, please kindly go back and watch our subsequent video on that, right? Once you watch it, you know how you do that this thing, right? So here we use what you call, we are just giving our data a name. This is what a variable name. So y is equal to read.csv, right? Then you type in this one to call your data from your desktop. In the other sense, you can also import, right? But when you use the directory, it's very simple. Right? So once I run it, see my data has come, right? This is the house data. You have the sepal length, the sepal rate, the petal length, the petal rate, and what species. These are the data that what we have in R. And then since we are learning about data cleaning and what exploration, right? I would like you guys to also know the structure, the data structure, right? The data structure helps us to know the different forms of what atomic data type that we have in our data set, right? Yes. So along the day, maybe you have this data, right? And then they ask you, the sepal length, is it a numeric date? Is it a numeric type or quantitative type, right? Yes. The structure of the data will also tell you what the data is, the individual columns that we have, the sepal length, the sepal length, the sepal rate, the petal length, the petal rate, and species, right? What are each different atomic data type of that columns, right? So we use the structure to determine that. So once you run, right? So when you come down here, our just tell us that our data frame, for our data frame, we have what we call, we have 15 objects, right? With what 5 variables. The 5 variables are the individual columns, right? Yes. And then once you come here, right, you see it, what R is saying. You see, it started from 1. And it's going to end at what 150, right? It's going to end at 150. 150. You see, 150 is the last distance. So we are having 150 observations as R is saying. And then when we come here to, we are having what 5 variables. 1, 2, 3, 4, 5. Right? So the structure is going to describe the data for the data frame, the number of variables you have, and then the number of observations you have. And then at the end of the day, you can see that for the sepal length here, we are having what a numeric type, right? Numeric data type. For the sepal rate, numeric data type, the petal length, numeric data type, and the petal rate, we are having numeric data type. But it's only the species that we have what character. So once it's character, you see it will always be put in a double quotation, as you can see down here, right? So the structure is going to help you to understand the data and understand it well, understand what your variables, right? So you doing testing for structure in what your destiny will help you to and appreciate more. And then second that I would like you guys to also know is that you have to get the summary of your data. The summary of the data is going to calculate the mean and then variances, the first quarter, second quarter, and then the rest, the median, for you to really see the central tendency of what your data, right? So here we have what we call the summary. As you can see here, we have what we call summary. So for this summary here, as you can see, right, for this summary here, as you can see, right, the summary is going to give us what the central tendency. So once you run, right, it's going to give us, right, so when you come to the sepal length, you're having a mean of what? A minimum of 4.3. You're having a first quarter of 5.10, 5.10, median of 5, mean of 5. Third quarter of that. So it's going to do that for the sepal, petal, and the rest. And you see for the species too, we have classes, right? Yes, we have classes. So these classes is going to give us the individual group that we have in what R for the sepal. Sorry, for the species, right? And then at the end of the day, for the test correlation to maybe after checking a lot of stuff, you can see that one of what the number of what columns that we have does not play an important role in the analysis. So you really want to remove these things from your data, right? We can do that simple, right? So R will help you to remove that column from your data. So for you to really remove the column from your data, we have what you just call your column from your data. And for you to be able to call your column from your data, you don't use only the data name. So the Y that you can see here is the data name you give to the data. So as you can see here, there's the Y, the data name you use to call our data from our desktop, right? So at the end of the day, you will see that you use your data name, right? There's the syntax, right? Data name, right? The dollar sign plus what the variable name. So here we have the data name. Our data name was Y, as you can see top here, and then dollar sign, and then the column that we want to remove from the data. So here we are using separate length, right? This is a separate. This is what we want to remove from our data, right? This is what we really want to remove from our data. So that's a separate length, right? Less than dash or equal to what? The now. So this now is going to tell her that, oh, I don't want the column, so I want to remove the column from my data. So once you run it, right, the separate length is going to remove from your data, right? So I don't know if you see, right? I did it, right, and I view the data again, and you could see clearly that the separate length has been removed from the data, right? So maybe you have done a lot of business analysis, you have checked your correlation, you have checked a lot, and you can see that this thing is not part. It shouldn't be part of the data. I want to remove it, right? You can use this one to also do that, right? And then we have what we call sort. Sort is going to arrange the names, right, or going to arrange a certain variables in order. For example, if we are really talking about the species here, for the species we are having different forms of what groups inside. You have the Setosa, right? We have Setosa, we have vesicola, we have Virginica, and a lot, right? There are only 3 groups in that. So at the end of the day, we want to sort that group, right? But we want to use the head because you don't want it to print all the groups, the individual different groups that we have in the different groups that we have in the data. We don't want to print all the 150 variables. So we use the head. Right, once you use the head, it means that we are going to tell her that I just want a specific number. I want you to print only the first 60 this thing for me, right? So here we are going to print what our first 120 variable group that we have in R, and then so the sort here will be sort into bracket Y dollar species, right? So at the end of the day, you can see that we are just calling what our species from the data. Right, this is how you call the species from data. Is the data name, right, into data name dollar sign, and the species is going to call the column of our species for us, and we are telling us that we want to sort. Right, as we are sorting, right, we are sorting this one, but we don't want you to sort everything for us. Give us all the listing that we have. Right, so you use the head and then tell her that I just want the first 121 groups that we have, right? So once you do that, it's going to print it for you nicely, right? How is going to print it for you nicely? So you see, she has given us the first 120, and it has arranged it for us by the first 120 variables that we have in our species, right? And also, you would like to, convert these characters into factors by using the factor function, right? Yes. So you see, for the species, they are full of factors, and also in our subsequent videos, I told you guys that once you see that there is quotation signs, a double quotation on your individual participant, like as you can see here, the Setosa and the vesicola, is telling you that these are only characters, right? So before you can perform a healthy analysis for your data, you have to convert these factors into what? You have to convert these characters into factors to help you in your analysis. So for you to convert these characters into factors, what you have to do is also use the factor function. So here we just use as.factor into bracket of the column name, right? So for us to get the column name, R is going to pick it by using this one. So I have already taught you how you call a certain column in your data. It's just the data name, dollar sign plus the column name, right? So as you can see here, so once I do this one, so you see that R has the double quotation has been removed from the data. So this is telling us that, oh, this is in factors, right? And then we want to convert these factors when we are doing the atomic data type. We want to convert these factors into what? Numeric. So if you really want to convert these factors into numeric, you use what? The arg.numeric, and then put in the whole argument. Since we didn't give it a variable name, since we didn't give the factor a variable name, you have to copy all the factor, this thing that you can see, and put it inside of the arg.numeric. So here, once you run it, right, you are going to get, so it's converting the setosa, all the setosa to be 1, and then all the vegicola to be what? 2, and what? The virginica to what? 3. So it has converted the characters to what? Numbers for us, right? It has converted the character to what? Numbers for us, right? And then maybe you want to really see it. You don't want to see it in the data like this. You want to see it in your. You don't want to see it at the console. You want to see it as part of what the data. If you really want to do that, you use the view function to also do that, right? And at the end of the day, we have what we call a table function. So what the table function does is that for the table function is going to count the number of groups that we have in your data. So for instance, when we come to this our data, the highest data that we have named it to y, we have what we call species, and the species here that we have in R has about, let's say, 3 groups, right? The species is having about 3 groups. As you can see, the levels here, the levels is that we are having setosa, we are having vegicola, and then we are having what? Virginica, right? So we are having about 3 groups. So it's going to count under these 3 groups. It's going to count the number of what? Participants that falls under what? These 3 groups, right? So we use what we call the table function to do that. So once you run it, so it will be the table plus what? The name of what? The column, of which I've taught you guys how you will get it, right? So we just run it nicely. You see, it has counted it, and it told us that the setosa is having what? 51 observation. The vegicola is having about 50 observation, and virginica is also having about 51 observation that we have, right? And then at the end of the day, you really want to, let's say, at the end of the day, you really want to, let's say, arrange your you really want to arrange your table in order, right? Yes. So for this table, I just said that setosa. I just said that just print the table for me, right? It's going to use the format how I has already arranged the species that we have. So here we have the setosa, right? Before this, after the setosa, you have the vesicola, and after the vesicola, we have what? The virginica, right? So I don't the R is going to print it according to what is in the data. So maybe I don't want R to print it that way. I want the virginica to come first. After that, the vesicola will come in the setosa, right? So I have to arrange it in order. So for you to be able to arrange it in order, you use what you call the order function, right? The order function. So this will be, you have your ordered function, and then the first argument here that you can see will be what? The column name, right? The column name, I told you that once you want to call it, the data name $sign plus 1. The column is that is in your data that you want to call, right? And then the levels, right? You want the levels, you want the virginica to come first. After virginica, you want the vesicola to come in the setosa, right? So I don't really, once you run it, right? Once you run it nicely, you see it has arranged it in the order that I understand want. So if you too can change it, and it will come in the order that you want, the groups that you have in your data. So at the end of the day, right? Maybe you have gone to the field to collect a certain data, but when you realize there is a missing value in the data, right, and you would like to maybe detect that missing value, the number of the missing values that you have in your data, so that you do or perform a certain analysis to remove them or to replace that missing value in your data, either to use the knn function to do that, or you can use the median to also do that, right? So for you to detect that there is or in other words, there is a missing data there is a missing distance in your data, what you have to do is that, so for here we are not going to use the Harris data, right? In our next video, I'll teach you how you can, when the data is even fertile for the analysis, I'll teach you how you can remove some of what we can remove some of the rows from the data, so that we can use that one to find. But for now, we are just going to use the vector that we treated in our third video. So if you haven't watched the vector video, kindly go back and watch it so that you really appreciate it, right? So at the end of the day, when we see this vector, we are saying that the second part is we are having NA here, we are having NA here, NA. It's telling us that we are having what empty this thing in our data. So at the end of the day, this is what our vector that we have. This is what our vector that we really have. So at the end of the day, for you to be able to detect the missing values, for you to be able to detect the missing values in your data, we can use what we call the s.na, right? The s.na is going to help us to detect the number of variables that we have that are missing from our data. So the s.na is really going to print for us either when we have when we have a missing value in the data, it's going to print true. But when the place is not missing, it's going to give us what? False, right? So it's going to give us logical answers, right? So here we just run this one. Once we run, you see it has given us false. So you see the second distance we are having any, so here is true, right? When we come here to we are having missing, so here is true. So it's going to give us. But what about when the data we are having a big data, the number of variables, the missing spaces that we have in our data too is very much, right? So how can we do this? That will help and make it very simple for us. We cannot just go through this one by one to detect, oh, this is 40, oh, this is 2, for us to know the number of this thing in the data, right? So what we have to do is also to use the assembly function. Once you use the assembly function is also going to summarize for you the number of missing data that you have in your data, right? So once you use the assembly function and run, right? Once you run it like this, you see it has given us the NAs that we are having in our data is what? 4. So as you can see here, 4. So when I come here, I can count, right? 1, 2, 3, 4, right? We are having 4 NAs, right, in our data. So we are having 4 NAs in our data, as you can see here, right? Yes. So the assembly function will even do it simpler for us. So we are having 4 NA functions in our data, right? So at the end of the day, you see, let's use the Harris data and see if indeed we have a distance. If indeed we have how do you call it? We have a missing data inside, a missing row inside, right? Once you do this none because the data is already prepared. So you see everything here will be false. Data we are having all the data to what? Intact. There is no missing value inside. When you do use the assembly function to, you don't see any NAs, right? You see everything here is intact. You are not seeing any NAs here, right? So at the end of the day, this is how we can also detect when there is a missing data when there is a missing row or column in our data, right? And then we can replace it using what? The histogram. So yes, we can replace it using the histogram to detect the median. Once we get the median using the histogram, we can use that median to replace that NA in the data, or we can use the mean to replace the NAs in our data, or we can use the KNN function to also replace our missing columns or rows in the data, right? And for you to plot the plotting histogram is not even very difficult, right? So for you to be able to plot the histogram, you just use the hist, that's the HST, right? The bracket of what? The vector name, right? That's the A. Or if you are using a data, it's not going to be A just like that from the data, but you are going to use the data name $, that column, right? So at the end of the day, once you run this one, it will appear nicely, right? So let's come here and see if this thing has come. Our plot has come. Let's come. So as I was saying, you see it has appeared nicely, right? So this is our histogram graph, right? So we just want to get what? The median, right? The median, that's the middle number, right? And then for us to get the middle number, you can use the histogram tool to get our middle number. And then here we are having just 5 different groups here, right? We have numbers ranging from 2 to 4, numbers ranging from 4 to 6, numbers ranging from 6 to 8, numbers ranging from 8 to 10, numbers ranging from 10 to 12, right? So if you want to count, you are having 5 different groups, 1, 2, 3, 4, 5. So the middle number will be this one. Once you get the middle number, just trace it to what? This one. We are getting somewhere what 5, right? Our frequency is what 5. So we are going to replace our n is using what 5, right? In our distance, so that it will help us to continue with our analysis, right? So I don't believe for you to fill using what for you to be able to fill the missing value that you have for your data, what you have to use is to, this one you have already done that, right? You have using the NAs to see the distance. So this code we are not going to run it, right? Let's use the replace, right? So the replace dash the NAs are the names, right? Just what the names, right? Yes, equal to, right? And then you use the if else function that you treated in our subsequent in our previous videos, right? So we use the if else, right? So the if else argument, the first argument that we have is what? The n is, right? We have the n is, right? N is what value, right? And that will be our first argument, right? And our second argument will be what? Our 5, right? The 5 will be what? The median distance that we got from the data, from the histogram plot. And the A will be what? The data name, right? Yes, the A will be what? Our data name, right? So that is how this thing is going to work, right? So you see, we have to just give it a name, right? The is.na into bracket of A. We already did that one here, right? That's the reason why I said I'm not going to run it, right? But for the sake that if the if else will run, let me run this one so that it will store this variable name in memory, right? So once I run, it has stored this thing in memory. So the if else will give us what the n is, the number of n is we have in that data, and replace it by 5 plus what the data name, and then we just run it. So once you run it, right, and then print, you see that all the n is that we have in our data has been replaced by 5. When it comes here, it's replaced by 5, and the rest of the n is that we have. So since you see here, we are not having the n is inside. So R has been able to replace all the n is that we have in our data by what? All the n is that we have in our data by 5, right? So we want to check the summary again if indeed we still have this thing inside, missing value. Once we check the summary, there is no missing value as compared to the other one. When we check this thing from there, we had what n is, right? So let's go and check down there. Yes, you see this one we are having n is, but when we use the if else, we are not having n is in our data out again, right? So that is how it will go. And then we have what we call the hist, right? The hist replace. You see, once we have 5, the interval from the interval from 4 to 6 have to be longer if we want to plot the histogram again, right? Since it will be in this way, 4 to 6. So within 4 to 6, that have to be longer because we are added 4, 5 to 8. The frequency must be longer, right? So let's run it and see if the frequency will be longer as I'm saying, right? You see, it's longer. The frequency is longer. At first, it was at 10, but here we are having about 13, right? Since we have added 5 different observations for on that. So this is just an example that I want you guys to try your hands on. So kindly try your hands on this, right? Just try your hands on this, right? Just check the structure, the assembly, the is, and the histogram, right? Just try it and then show it to me at the comment section. Right? Thank you for joining this channel. Thank you for watching the video. This is Statistics and Mathematics Tutor channel. Right? Kindly subscribe, like, and share to your other colleagues so that they too will really understand R. Because you knowing how to use R to do analysis contain a lot, right? You have to know all the basics stuff that is necessary for you to be able to do that. So thank you for joining. Bye. Have a blissful day.